Welcome to Finding the Limiting Reactant. So, for a given chemical reaction, particles react and form only in the particle ratios shown in the balanced equation. In any reaction between two substances that goes to completion, there are two possibilities for the reactants. Either the particles are mixed in the exact ratio needed so that each of the reactants is completely used up, or one of the reactants is used up and some amount of the other reactant is left over. And let's look at each of these cases individually. When we ignite hydrogen in the presence of oxygen, it burns rapidly. In other words, it explodes. So 2H2 plus O2 yields 2H2O. If we have 4 hydrogen molecules, then they will need 2 oxygen molecules in order to burn, and 4 water molecules will be produced. If one reactant is mixed with another, and both are completely consumed in the reaction, then the reactants that were initially present were in a stoichiometric ratio, or in stoichiometrically equivalent amounts. For example, if we have 4 moles of hydrogen and 2 moles of oxygen, then we have a stoichiometric ratio of our reactants because we have a 2-to-1 ratio. And that's what we need in that balanced chemical equation. And after the reaction, that means after our explosion, we will then have 4 moles of water, we'll have 0 moles of hydrogen, and 0 moles of oxygen left over. Now, many times we're asked to find the amount of one reactant that will be needed to completely react away an amount of another reactant. And we can solve these types of problems using the steps that are outlined in section 9.5. Now, we often try to mix our reactants together in a stoichiometric ratio, but we can never get our reactants in exactly the right amounts to have none of either left over. In reality, we're going to have some amount of one reactant left over once the other is all gone, even if it's a small amount. So, suppose we have 4 hydrogen molecules and 1 oxygen molecule. That 1 oxygen molecule will react with 2 out of our 4 hydrogen molecules to form 2 water molecules. And so now we've used up all of the oxygen, but we still have 2 hydrogen molecules left over. Now every reaction has at least one limiting reactant, which is also sometimes called the limiting reagent. Now the limiting reactant is the reactant that's used up first. So this reactant limits how much of the other reactant is used up and how much product can be formed. So in our previous example, the oxygen was the reactant that was used up first, so the oxygen is our limiting reactant. Reactants that are not used up are what we call in excess. That is, there's enough of that reactant present to use up all of the limiting reactant, and some will still remain when all of the limiting reactant has been used up. So the hydrogen that we had in our previous example was in excess. We had 4 molecules of hydrogen, and at the end we still had 2 molecules left. That means we had hydrogen molecules in excess. So which reactant is the limiting reactant depends upon the starting amounts of each reactant and the ratio in which those reactants react, which means the reaction coefficients in our balanced equation. And note that the limiting reactant is not necessarily the reactant with the smallest amount of moles or grams, because we may not react those in a 1-to-1 ratio. If we have a ratio between our reactants that is not 1-to-1, then we may have the same number of moles, but whichever one is being used up faster, that's the one that will be used up completely first. And that one is then the limiting reactant. So, in calculations for reactions that go to completion, one reactant must be limiting, and the initial amount of the limiting reactant determines how much of the other reactants actually react away and how much product forms. The initial amount of the limiting reactant is used as the given to calculate how much of the other reactants react away and how much of our product forms. Now, the initial amounts of reactants in excess do not determine how much of other reactants react or products form. Also, if a reactant is in excess, then its amount is more than enough to use up all the limiting reactant, and measurements of its amount are not necessary in calculations and can then usually be ignored. In the special case, when 2 reactants are mixed in a stoichiometric ratio, both are limiting, and either one can be used to determine how much product will form. So suppose that we start with 10 molecules of hydrogen and 6 molecules of oxygen, and the reaction goes to completion. Which reactant is limiting? How much water can be formed? And how much of each reactant and product is left at the end of the reaction? I want you to pause the video and write down your answers to these questions before you go on. So, which reactant is limiting? For 10 molecules of hydrogen to react, they're going to need 5 molecules of oxygen. We have more than 5 molecules of oxygen, so oxygen is not the limiting reactant. For our 6 molecules of oxygen to react, they're going to need 12 molecules of hydrogen, but we only have 10 molecules of hydrogen. So the hydrogen is going to run out before we can react away all of that oxygen. That means hydrogen is our limiting reactant. So the next question is, how much water can be formed? When we react away all 10 of our molecules of hydrogen, remember that hydrogen is our limiting reactant, 10 molecules of water will be formed. Now last we wanted to know how much of each reactant and product is left at the end of the reaction. Now for hydrogen, this was our limiting reagent, and thus there's none left. For oxygen, we needed 5 out of our 6 molecules in the reaction, and that means that we only have 1 molecule of oxygen left. For water, we formed 10 molecules of water in the reaction, and that's how much we're going to have remaining at the end. So previously, we've learned to solve 3 types of questions about stoichiometry of reactions that go to completion. We've learned to form a given amount of product, what amount of one reactant must be used up. Given a known amount of one reactant and an excess amounts of the other reactants, then what amount of a product can be formed. And given a known amount of one reactant, what amount of a second reactant gives the stoichiometric ratio. You should already know how to solve each of these. If you don't, then you need to go back and review some previous videos. In each type of the problems listed above, an amount of only one substance is given. And to solve, we use the 7 stoichiometry steps that are explained in previous videos. But we're now going to look at problems in which amounts of 2 substances are given, and we're asked to find the amount of product formed. So unless we're told which reactant is limiting, we need to figure out which reactant is the limiting reactant. That is, if an amount of product formed is wanted and 2 reactant amounts are supplied, you must first determine the limiting reactant and then use that limiting reactant amount to solve to determine how much of our product can be formed. So with simple cases, you may be able to identify the limiting reactant by inspection, as we did with the combustion of hydrogen earlier. But with more complex cases, we need to use successive conversions. So let's look at successive conversions. Remember that in the data section, an amount of a substance will always be measured by a single unit. So this is something like grams, moles, molecules, perhaps liters. If single unit amounts for 2 different reactants are given to us, then in 2 separate stoichiometry conversions, start with the same unit and product formula wanted, but use each reactant amount as a given. The calculation that results in the lowest amount of the wanted substance formed, that product formed, is the one in which we started with the limiting reactant. And then label this reactant as the limiting reactant. And then, if we're asked to calculate the amounts of other products that form, use the amount of our limiting reactant to determine how much of the other products form via similar stoichiometric conversions. So let's look at an example. How many grams of water will form from 2.00 grams of hydrogen and 4.80 grams of oxygen? Let's write the wanted and data sections. We want mass of water, so we have grams of H2O. We know that we started with 2.00 grams of hydrogen and 4.80 grams of oxygen. We know that the molar mass of hydrogen is 2.016 grams of hydrogen. We know the molar mass of oxygen is 32.0 grams of oxygen. We know the molar mass of water is 18.0 grams of oxygen. We have our balanced chemical equation down here, and that means that we have 2 mole-mole ratios. We have a mole-mole ratio between hydrogen and water, 2 to 2, or 1 to 1. We have a mole-mole ratio between oxygen and water. So this is 1 mole of oxygen to 1 mole of oxygen to 2 moles of water. And now we can write the solve section with our 2 stoichiometric calculations. So in the top one, we're starting with mass of hydrogen. So grams of hydrogen will cancel. We've converted that to moles of hydrogen. Then we convert from moles of hydrogen to moles of water. Then we convert from moles of water to mass of water. And that then gives us 17.9 grams of water can be made from our 2.00 grams of hydrogen. In the next calculation, we start out with our mass of oxygen, 4.80 grams of oxygen. We convert from grams of oxygen to moles of oxygen, convert from moles of oxygen to moles of water, convert from moles of water to grams of water, and we find out that 5.40 grams of water can be made from our 4.80 grams of oxygen. Now, the lower of our two is 5.40 grams of water, and that means that oxygen was our limiting reagent, our limiting reactant, and we're only going to be able to produce 5.40 grams of water because we're going to run out of oxygen before we run out of hydrogen. Now I want to point out here, we had a larger mass of oxygen than we had of hydrogen, but because the molar mass of hydrogen is so much lower than the molar mass of oxygen, we run out of oxygen before we run out of hydrogen. So we can only make 5.40 grams of water with the 4.80 grams of oxygen, so the O2 is our limiting reactant. And note that O2 is the limiting reactant even though we started with a larger mass of oxygen than hydrogen. So that was finding the limiting reactant.